Thank you for joining us to another Center Elevation webinar. I'm your host, Nando Mogollon, and today we will be touching base on functional checking and showing a few samples for that. Now, we won't be able to cover absolutely everything that is included into the topic of functional checking because it's as broad as anything like model coordination or class detection, but we'll try to do the best to cover the following points. We want to do a few samples, checking for clearance and unobstructed doors, meaning that you want to check that doors can actually function within the spaces that they're being provided for. In this case, we're going to use a toilet, just a typical clearance back in front of the door, and we'll try to show you the way we perform those checkings. Same thing. But in this case, for light switches, just moving away from just purely architectural elements and into services elements. One of the things you're going to check is make sure that the light switches that are being provided are not being obstructed by anything around it. And you can provide an area that is required to be clear for them to be accessible. Same thing. And this one is not an actual functioning based on human accessibility, but rather making sure that something that requires a good level of unobstruction, like air terminals for diffusers and air nozzles, they should not have any other elements within an area in front or below them. And depending on whether how badly that happens, then that might be a problem that requires to be sorted out, or it will just imply some issues for the efficiency of the system. So these are the kind of things you want to pick up on a model that are slightly harder to pick up, or time consuming to pick up when you're looking at a plan on a plan view. And then the last one we're going to run through is it's actually one that we found in the last couple of months rotating around, I believe it was LinkedIn. And it's a picture showing an obstruction of having a column in front of an ATM, I believe. So I'm going to show you the picture first. We did actually remodel that and put it into Solibri just to show you, a sample on how to pick that up if it happened to be in your models, a situation kind of like that, although this one is pretty odd, but we'll run through that. Now, not related to this particular webinar, but we'll do it on the next one. On the next webinar, we're going to run through the type of checkings for model quality that are code related. Now, building codes will vary depending on the project type and depending on the both city and countries that you're in, but they tend to look at pretty much the same things: accessibility, minimum spaces, fire codes, and structural codes. So we're going to try to run through those, some fairly neutral examples, just to make sure that they are related to the area where you practice. We're going to run through that on the next webinar. And then we're going to do just now, we'll be running through the exercise, checking for these 4 different things using Solibri Office. So without any further delay, let's jump to Solibri. All right. So the first one we're going to check, and this time we won't be using our typical high-rise building, just because we don't have enough cross-disciplines models in that to be able to check for realistic things like we're checking this. So this time we're using a model that comes within Solibri. So if you have downloaded Solibri anytime lately, you'll have access to this sample model. Now, we have added quite a few things in there just to make it a little bit more interesting, I'll say. So one of the things we have in here is we've got the basic Solibri model, but we also have some furniture and joinery that will add to the complexity of the whole thing, making it more of a real example. We also have loaded the services model. In this particular case, we have both ventilation for air supply and the returns. And we have like a basic electrical model there that doesn't really contains more than, let me show you that, just a few lights and the switches. And we're going to use these particular switches in here to prove the point of running a functional check where we're actually checking that against some kind of clearance. So those are the models we have in here. We also have a few structural models, the typical concrete, and we have added a few steel elements, just again to make it a little bit more interesting. And that's pretty much it. So the combination of all of those will give us what is simulated to be a real life project. Now, let's go with the checking. So what we have here on the up left, as you may be aware of already, that's the area where Solibri runs the so-called rule sets. And we have created a rule set called functional check, just to give you an example of the kind of things we'll be looking for. Let's start with the doors. Now, for these doors, we're using two separate rules that come with Solibri, and we have customized those two doors in order to find the actual obstruction with them. Now, before we go through the results of the checking, what we're going to do is to check what the actual rule is doing. So the first one we're going to take a look at is this one here, which is rule number 226. For those of you who are currently using Solibri, you may want to take a look at that. So 226 is a fairly flexible rule that essentially checks clearance of certain areas that you can define, given this preview box in here, within a certain number of limits. So you can adjust the area in front of an element based on the depth, height, and extension to the sides of the elements that you're checking. Based on these numbers up here, there are a few exceptions that you can allow certain elements to be within that space in case of them being accepted, kind of floating elements if you have some of them. And essentially what you do is define what are the elements you want to check. In my case, we're checking for clearances in front of doors, so we're going to include doors of the architectural nature. And then you can also add certain inclusions. So these are going to be, whatever kind of additional elements that you want to accept from the checking. And those could be, multiple different elements and so on. And these are going to be allowed in front of it, or in front of the area. Depending on how do you want to run the check, you may want to include or exclude, or even ignore, which is also an option here, whatever elements you wanted to either exclude or ignore. So again, rule 226, and it runs through that kind of checking. Now, let's go and check what that particular rule just did. So we've got the results down here. And with the results, once you click on the top item there, the folder, that's essentially combining all the results through the model, which in this case is combining about 3 of them, actually. When you check this result summary here, that's going to tell you 3 for these doors in here, and 1 that it's not a bigger issue, but it is still an issue back there. So let's go through the details, and we're going to see how the settings of the rule have affected the way Solibri actually finds the issues. So the first one, the one with the most severity, that's why that one is in red, it's actually checking the clearance for those doors. Now, more than being a clearance problem here, what we have there is an actual clash. So it's good to be picked up. Usually you will have picked that up already by a clash detection rule, or even these or another software checking for that. That's odd, that should still be happening, but it's still happening and will be checked because nevertheless the rule is checking for clearances. The column in this particular case is actually in the way of the clearance of the door. So even if it wasn't really clashing or just in front of it, it will pick that up. So that is a problem. Let's go double check the other one. So lower severity, but still a problem. And you can see how this is not a real clash. So there is no clashing between that column and the door itself. But given the defined space that we want to provide, or that we want to make sure that it's clear, both back and front of the door, you can see how that door actually doesn't have the clearance necessary behind it. So that will be a problem, and so we will be able to pick that up essentially for the case of functional checking, saying, hey, that door doesn't really work if you keep that column there. So there is an actual problem right there. So that will be for this unobstructed general rule for, I'm not exceptionally telling Solibri which doors belong into which spaces or anything. Check go all the doors, and then it came back with that. Now, if we want to do specific checks with more accurate dimensions, then we can use this second rule in here. That is rule 208, and that is a slightly different rule, far more, how do we call it? It's far more specialized in checking doors. Now, this is the kind of door that will be particularly interested in finding doors per space. So you can tell it, hey, I need you to check these particular spaces, not just any space, because depending on the space, they may have special requirements. Let's say the one we have in here will be for toilets, and then within certain toilets or certain types of toilets, we want to make sure that the rule is being checked against certain requirements. Now, probably the one thing that I want you to take a look at, because it's very common, will be these particular requirements. If I double click on that, it's going to bring about this preview here with all these different boxes or ticks that you can actually go and check. So it's, in general, it's quite a complex setup, but the good thing is it is very precise. So you can set up any particular distance, both lateral and in front of whatever areas around those particular doors. And then you can set it up both in the front or on the back. You can specially indicate which type of spaces these requirements will apply for. So those will be that WC, which is the one that I've defined up here. And if I include more, then more will be available. And then you essentially just check minimum width or any other specific areas around the building, like clearances around and in front of it, which is essentially what I'm checking for in this particular case. So one of the things we're checking for here in Australia, we don't really use 110, 150. We use actually 110, depending on which direction are we approaching the spaces, and depending on the conditions. So there are 6 or 9 conditions on that. So we're not going to get into the details of that. What I want to show you is that you have the ability to change that depending on any kind of conditions. So ghost checks for that. There are some elements that might be ignored. For instance, switches and electrical terminals are not a problem, since they might be behind the door, and that's okay in some cases. And the spaces, of course, because the spaces do not represent a problem for them. That being everything else, it's fine. So essentially, you're checking for that particular item there on 228. Check for that. Go through the problems. According to this, we essentially have just 2 problems in some spaces. Let's go. One, it's again a circulation and the toilet. So let's go and double check what the problems are. Okay, so this is one, and as you can see, that is one of the toilet rooms. And the problem in here seems to be that the lateral clearance, it's not provided. So this one here seems to be, the front clearance is fine, but the lateral clearance of 150 as defined there is not enough. So this is probably closer to the 150. In case you want to measure that, just remember, you just need to go through these. Let's check that. Yeah, it is only 59 millimeters according to this, which is clearly not the 150 that the rule is requiring. So those are bits and pieces that might be difficult to pick up when you're just checking a floor plan, but they'll be relatively easy to pick up when you're using Solibri as a tool for that. So that's going to be checking up clearances specifically for doors. So you can have just a general rule that checks for unobstructed doors back and front, and then another one that checks specific requirements per spaces. I believe this is going to be pretty much the same. Yeah, exactly the same problem, just a level above or below, I believe. Okay, so that is for doors. Let's go and reset here. Now, remember I have these electrical switches all around the building. Now, if I'm gonna go in here, let's switch that to game mode so I can jump inside. Let's see if I can show you some of those. So, there you go. So, got some of them from level 1 and so on. So these are the switches we're talking about, right? We've got quite a few of them all around the building, and we want to check essentially that they have enough space around them so that a person can actually reach them with their hand. That's requiring these particular rules to run certain clearances. So for this, I'm actually using the same rule that I've used for the unobstructed doors here. That is rule 208. And essentially what it's doing is checking, sorry, not that one. This one is not 208, 226. This one here, it's checking the clearance, but not for doors. Now, in this particular case, I've added just electrical components that are switches. Now, I've added just the specific switches that I'm using in this project because I want to be very specific and not simply just find any transformers or what an IFC transformer will be. So what this one is checking, if you have an imaginary area or volume in front of the switch, this one is essentially checking for a 700 millimeter depth, so kind of a person standing in front of the switch, and then a 200 millimeter width, so kind of allowing for someone with busy hands or something like that to be able to locate and actually operate the switch, therefore providing good operability or functionality of the switch. Now, those values are completely made up, but just for the sake of giving you an example of how these will be used. Ignoring spaces, as they must be, since spaces do not represent a problem for obstruction. All right, so we'll take that. This is going to give me just one problem, as you can see there, right in that area. Back here, problematic areas. Now let's go and take a look in close at what the problem might be. Okay, so this is the area we're talking about. And what's going on in here at the moment is essentially that the switch itself that one here, it seems to be too close to that little piece of wall on the side. Now, when Solibri find these issues, they may provide already a markup, like so. I'm just going to extend this for a little bit so that you can see the actual extension of the area. And you can tell how, the volume that was provided for the switches to be cleared up is not enough given that little bit of a corner on the right hand side. So still not a critical problem, but it's somewhat of a problem, and it just didn't pass the rule. So you'll be able to pick that up. It will, if it was a much of a critical problem, maybe a piece of furniture in front of it, that'll be something you actually want to know, or a piece of joinery, in case of a switch being misplaced, and then you want to correct that. Access to light switches, like so. Now let's check another one. This one kind of belongs to the area of services coordination, I believe, but since most people would relate that to be simply a clash detection, it is worth checking, or is it worth demonstrating that that's the kind of things you can do when you're checking for functional items. Since air supply terminals like diffusers and air nozzles, they only work well when they have a certain amount of space clear in front of them. Now, what you want to do is pick that up before they start construction, so that any changes happen on the paper, not when they are on site already building up the ducts and putting up the diffusers. Rules that I'm using for this, in this particular case, that's another type of rule that is quite flexible and quite useful for many purposes. This is rule 222. And that rule is component distance. That's the name of the rule. And essentially what it allows you to do is to check for clearances or proximities in between elements. In this particular case, what we want to find is having vertical diffusers. Let's start with those. Making sure that there is a required minimum distance from the diffuser to the next element of minimum 2 meters. Again, made up, but it will do what I'm looking for doing. So these ones are essentially looking for the space or the footprint of the actual diffuser with an additional offset on the perimeter of about 200, then providing some sort of a cone, if you like, from the diffuser downwards. Make sure that there's nothing in the next 2 meters directly below them. Again, excluding spaces, including everything else, containing all the terminals that are of the air supply, not the return, just air supply. So we've gone through that check, runs the check, finds, according to these 3 particular issues, which we want to go and take a look at. Let's start with the ones in the ground floor. Let me reset the view so that we can go. So that's one. And again, not quite a clash, because they're not clashing. What this is indicating is essentially that you have, or we have, the horizontal diffuser there, which is too close, provided the 200 millimeters to the sides. It's far too close to that particular beam. So that might provide some level of either discomfort or just not working altogether. That needs to be defined by a mechanical engineer, but it will provide some level of accuracy in how the element will work or not work. So someone will need to go and check that up. This one is pretty much the same, although this one is also a hard clash. So I wouldn't be surprised if that had been picked up already by clash detection. That's still being picked up right here. And then another one on the second floor. This one is a little bit more tricky. Even though this one is being, this was essentially intentional for you to see the different type of checks. This one is essentially clashing with that beam. But what is interesting is that it's also being able to pick up the joinery down there. Now, that might or might not be an issue. But what is interesting in here is sometimes you want to prevent, let's say, diffusers to be directly placed or being precisely above certain particular pieces of equipment, even if that is the case. In some cases, these air supplies may have issues with dripping or certain other problems, and some items may need to be required not to have a direct air supply right above them. So these will be very handy to know. And again, you can define what's going to be the vertical distance. This is within the 900 millimeters, which is much less than the 2 meters that I have required for the clearance. So that one will help quite a lot. And again, this is rule 222 for component distance. And another way to use that, which is, I've used that in here for wall-mounted terminal supplies. And what I mean by that is, let's do it with this. So the mechanical system, the ventilation system we have in here has two types of air terminals. We've got, well, essentially in red, you've got air supply. In yellow, we have the return. But with air supply, we have vertical diffusers and horizontal diffusers. Those are essentially pointing down. These ones are pointing to the side of the walls. So since these are going to have walls below them, then essentially they won't be able to work with the same rule. So we have created a separate rule, which in this particular case, it's the clearance rule that is checking the spaces in front of the elements. So we've defined this to be set for 200 and 700 millimeters, just to provide some level of volume right in front and to the sides of those diffusers. So we go and check if there are any problems. There's just one particular issue right there. It might be a lateral issue, but let's go and check. So yep, that's what it is. So according to the rules, we've provided a 700 millimeters, which is checking against that particular beam, saying, hey, that is far too close, and that might be an issue. Let me reset this for a bit, just to be able to see the entire picture, and that's exactly what it is. I believe I have ignored pipes of a certain size. That's why that particular pipe is not being detected. But if I wanted to, I can include those bits and pieces just as well. And like that, we'll figure out whether that either works or doesn't work for the purpose of functional checks. Now, this is essentially what we have on this particular file. And now, as an extra, I wanted to add this other example that, again, you probably have seen that on the internet. And we did invite the person who picked that up and put it on the web. Quite an odd situation. I tend to believe that this is just a problem with some sort of a renovation, and this is just an afterthought, and clearly someone had to be punished for that. But if you really wanted to double check for that using models, that's perfectly possible. Now, what we have done in here is essentially we have remodeled the same problem, and we have, hold on, let's stop this. What we have is just an ATM right there, which has been included inside the wall. So there's an opening for those things. And because it gets sort of embedded into the wall, if you like, they have been classified as an electric appliance of a certain name. So I've added the name ATM so that I can identify those. Those are just regular columns, a wall, slabs, nothing irregular for the rest of the building. And as you saw in the other example, I've used this very generic rule for the component distance alongside in this particular case, where essentially what this is doing is going and checking for these electrical appliances. You probably want to go and, you have far more than just one, which is my case. I will just go and say, be very specific, maybe saying just go for specific names, maybe, where I'm just looking for the ATMs, for instance. And then it will check the ATMs against, a bunch of other items on the side. So once we check for the rule, it will find the problem and essentially will tell me, look, this ATM is far too close to the column in this particular case. So the space is not enough. And then providing a good result for that kind of checking. Notice that you can also check for, sorry about that. You can also check for which components have passed, because I don't know if you noticed, but we do have another ATM in here on the side. So you can check for the elements that have failed, in this particular case, that one, or check for the elements that have passed. This particular case, the other one on the left-hand side. And that's the functional check. All right. Now, that's enough for the functional checking on these two particular examples. I hope that those two samples were useful for you guys. Also apologize, we've got a barking dog on the background for the whole time. Really hard to control that, so my apologies for that. Other than that, please make sure you subscribe to any future webinars. And again, next week we're going to run a couple of other examples, in this particular case using code-related examples. And you'll be able to register to those webinars just by using that calendar provided on that link, or using your phone on that QR code. That's also going to take you to the same link on a shared calendar where you can register for any future webinars. If you're in Australia or New Zealand, you can get help from Central Innovation through myci@centralinnovation.com, or using the support hotline, or the support emails are as they are described there on the screen below. Stay tuned for next week's webinar, and have a good time in the meantime.